PHY2048. Okay. Now what else do we need to find? When the box begins to move, the friction opposing motion is the force of kinetic friction F sub k. Alright? When the box begins to move, the force that is opposing motion is no longer the static friction but the kinetic friction, that is F sub k. There you are. So F sub k equal to mu k Fn, and mu k is given to us. That will be 0.3 times 29.4, that is 8.82 Newton. Well, if T is the new tension on the string, then the net force pulling the box to the right will be F net equal to T minus 8.82. That will be, well, this will be the net force, and this net force will produce an acceleration on that mass such that F net equal to ma. So T minus 8.82 will be equal to mass, that is 3 kilogram, times its acceleration. And we have another equation, T minus 8.82 equal to 3a. And we need to calculate the acceleration and the tension on the string. Now what is the net force now on the 2 kilogram? You notice that the tension on the string is not the same as the tension in the previous case, because when the system begins to move, the forces have changed. Therefore, the tension force will change. So we cannot use this T to be equal to the one which we solved in part A. The tension T will be different. Now, what are the forces now acting on the 2 kilogram? Well, the 19.6 will be acting vertically down, and the tension force will be acting vertically up. But the system is now moving down. That means there is a net force. What is that net force? That net force will be 19.6 minus that T. So F net equal to 19.6 minus T, and that net force must be equal to mass times acceleration of that mass. Now you have two equations. The first one is T minus 8.82 equal to 3a. The second equation is 19.6 minus T equal to 2a. Can you solve these two equations quickly? Well, rearranging this, actually you don't need to rearrange this. Do you know, if you add equation 2 to equation 3, can you add equation 2 and equation 3? Add the left hand sides. When you do that, the negative T will cancel with the positive T. In other words, we will get 19.6 minus 8.82 will be 2a plus 3a, that is 5a. And you can calculate a right away. Well, let's go this way. Rearrange equation 1. T minus 3a equal to 8.82. And this equation, when you rearrange, take the negative 2 to the right side. It will become T plus 2a equal to 19.6. And you can solve these two equations without any trouble. Well, this time, let's subtract the top equation from the bottom. Now look at the way I'm going to subtract. T minus T is 0, so the T's will go. 2a minus negative 3a is 2a plus 3a, that is 8a, equal to 19.6 plus 8.82. So you have 5a, is that right? 5a equal to 19.6 minus 8.82, and you can calculate a from there. and solving gives you T equal to 15.3 Newton and A equal to 21.6 meter per second squared. Now this is a very important type of problem, and it'll be useful that you learn how to solve these problems. Okay, let's move on to the next problem. Well, we need to complete that problem. The question is, once you calculate the acceleration, we need to know how long will it take for this object to reach the ground. The 2 kilogram mass has an acceleration of 2.16 meter per second squared. We just calculated the previous slide. The negative sign indicates that it is downward. So you need to now use the value A equal to negative 2.16 meter per second squared. So this mass is moving down with an acceleration A equal to 2.16 meter per second squared. And we need to find the time taken for it to fall through a height of 2 meters. Well, I haven't carried the whole of that question, so you need to go back and refer to that question. We need to find the time taken by this mass to fall through a height of 2 meters. Well, now that you know the acceleration is negative 2.16 meter per second squared, and y equal to 0 is at 2 meters below where the mass is. So we need to find the time taken for this mass to drop through 2 meters with an acceleration A equal to negative 2.16 meter per second squared. Can you tell me how to do this problem? What is the time taken by an object to drop through a certain height? The initial velocity here is 0. The initial velocity is 0, and it drops through a height y0. What is the equation that will help you to find that time? Well, we know y0. We assume that this is, well, initially the initial velocity of the object is 0. v0 is 0. We are looking for the time taken by the 2 kilogram mass to fall to the ground. That means the time taken for the y position to become 0. Is that right? This is the ground. Now, this is y0 equal to 2. We need to find the time taken for that y position to become 0. So that obviously you need to write down the position function. What is the position function for this object? Y equal to y0 plus v0t plus 1/2 at squared. Now here, we need to find the value of this t when this y becomes 0. And you know y0 is 2 meters, v0 is 0, and so all you need to do is set this y equal to 0, replace y0 by 2, and use the value of a. What is the value of a? A is negative 2.16 meter per second squared, and solve for the time. So 0 equal to 2 plus 0 plus 1/2. A is negative 2.16 t squared. Now, that will be, you can see, this will become 2 minus, what is 1/2 of 2.16? 1/2 of 2.16 is 1.08. So this will be 2 minus because of this negative sign. 2 minus 1.08 t squared equal to 0. or 1.08 t squared equal to 2, and therefore t squared equal to 2 divided by 1.08, that is 1.85 seconds squared, or t equal to 1.4 second. So under these conditions, when the system begins to move, it will take 1.4 second for the 2 kilogram object to drop to the ground. Now, another very important type of problem, and I want you to practice this problem one more time. All right? Another one. An automobile is going up a grade of 15 degrees at a speed of 30 meters per second. The coefficient of static friction between the tires and the road is 0.7. What minimum distance does it take to stop the car? B. What minimum distance it would take to stop the car if it were going down the grade? Now, what is the difference between the car going up the grade and the car going down the grade? Well, there is a big difference there, and I want you to be very clear about it. Now tell me, when the car goes up the grade, what are the forces acting on it? Now, when the car is moving up the grade, what is the direction of the frictional force? The frictional force will be down the grade. So, the forces acting on it are mg sine theta, that is the component of the weight pulling it down, and the force of static friction, which will be mu s mg cos theta. I hope you are now familiar with these. The frictional force, the force of static friction will be mu s mg cos theta. So when the car is moving up the grade, the forces that opposes motion is mg sine theta, that is pulling the car down, and the frictional force that is opposing the motion. Now, these two forces are the net force on the car, which produces the acceleration. We can therefore find the acceleration, which will be a negative acceleration. And once you have the acceleration, we can find the time taken by the car to stop in a certain distance. Is that right? Okay. Now, when the car is going down the grade, what are the forces now on the car? The difference is, when the car is going down the grade, mg sine theta is always down the grade. But when the car is moving down, the frictional force will now be up the plane. So, when the car is now moving down, mg sine theta is down the grade. Mu k mg cos theta, which is the frictional force, will be acting up the plane. And the net force therefore will be, the frictional force minus mg sine theta. It is that net force that stops the car. Well, here we assume that the frictional force is greater. Otherwise the car will never come to a stop. Is that right? And therefore, in the case when the car is moving up the grade, the net force trying to stop the car, or the net force that produces the negative acceleration on the car, is mg sine theta plus mu k mg cos theta. And when the car is going down the grade, the net force producing the acceleration on it is mu k mg cos theta minus mg sine theta. Alright, let's now write that down.